Okay, so the next part of this, so isotopes. We want to mention isotopes. So isotopes, they're elements, right? But what happens in some elements is the number of neutrons can change. Okay, so protons stay the same. Okay, so protons always stay the same in an element for what we're doing, right? Okay, so protons stay the same, and they're going to determine, that's going to tell us what element it is. But the number of neutrons can change. So when the number of neutrons changes, that's what we call an isotope. Okay, so isotopes are variations of an element that differ in their neutron number. Okay, so it's going to change the mass of the element. So it's going to change how big it is, right? Um, Isotopes are not, they're less stable, so they don't necessarily want to be that way, but it happens. It just occurs in nature. Okay, so they can decay over time. Okay, so they break down, and when they break down, they emit energy in the form of radiation. So this is nitrogen 15 as an isotope. So it's got 7 protons, but instead of 7 neutrons, it has 8. Okay, so it's got an extra one. The electrons don't change. So there's some things like if anybody has had thyroid problems, there's radioactive iodine. In research, we use radioactive phosphorus, so they call it P32. They use, you might have heard of carbon-14 dating. Okay, so that's an isotope. So we use them, uranium, things like that. So isotopes are they have a different, it's the same element because the protons are the same, but the number of neutrons change. Okay, now, another thing that can happen is that this has the same heading as the last one, I'm using the things from the book, but now we're going to talk about ions. Okay, so sometimes things, then sometimes in elements and atoms, the number of electrons changes. Okay, so if the electrons change, then we call it an ion. Okay, so if nitrogen atom gains 3 electrons, is it positively or negatively charged? Okay, so I want you to remember, I'm going to make you a little chart here. So we're going to have protons, we're going to have neutrons, we're going to have electrons. Okay, and on the first column, I'm going to put charge, which I can't write with my mouse like this. Okay, and then we're going to put mass. Okay, so this little chart is like your cheat sheet for this. Okay, so protons are positively charged. Neutrons are neutral. Okay, so they don't have a charge. I'm ignoring my phone, right? And electrons are negatively charged. So you have positive, neutral, and negative. Okay, now mass, remember protons have mass, so we're going to say their mass is 1. Neutrons have mass, so that we're going to say their mass is 1. But electrons don't, they're really, really small, so we're saying they don't have a mass. Okay, so if we look at the charge, okay, so protons, this would be +7, right? Neutrons, that's neutral, so no charge. Okay, and electrons, that would be 10 negatives. Okay, so this is almost like you're overdrawing your checking account. Okay, so you're going to take +7 and add it to -10, and that gives you -3. So because you added negatives, so you added electrons, which are negative, okay, it's negatively charged if it's got more electrons. And you can figure that out logically just doing addition, right, and doing math. Okay, now there are 2 different ways that molecules or atoms can bond together. Okay, so one is they can share them. Okay, so they can share electrons. And the other one is they can actually transfer electrons, and they create two different, like a positive and a negative atom. Okay, and this is just one of those questions where they're trying to get you to think about it. So which two types of these bonds do you think might be stronger? Okay, so just keep that in mind for a minute. Okay, let me get rid of my pink pen here. Okay, so now the two types of bonds that we have is we have ionic bonds and we have covalent bonds. Okay, and this little chart organizes it. I like charts and tables. It's, for me, they're easier to see. Okay, so chemical bonds. So ionic bonds is when we're going to transfer electrons. So that means we have something that's positive and something that's negative. Okay, now covalent bonds, this is when we're sharing electrons. Okay, now in a non-polar covalent bond, okay, we are sharing the electrons equally. Okay, so everything is good, it's equal sharing. But in a polar covalent bond, there's unequal sharing. Okay, so they're not shared equally. Somebody's hogging the electrons or taking all the electrons. Okay, and I always think of if something is polar, right, you're at opposite ends of something, right? So that tends to be unequal. Okay, now one thing that I need you to see, and I'm going to try to do it on the next slide. So hold on. Is how electrons are organized in the cell. Okay, so not the cell. I'm sorry, guys. I'm trying to change slides and talk, and I'm not multitasking well. Okay, now in an atom, okay, we have the nucleus. So here's the nucleus. And then around that, we have the first orbital. And the first orbital can hold up to 2 electrons. So pretend these are electrons, these little pink things. So here's one and here's another. So that's the first orbital, and that's all the electrons it can hold. Okay, the next orbital, which these are bad pictures, right? Let's get green. Okay, so this is an electron. This is an electron. The next orbital can hold 8. Okay, so the first one only holds 2. The next one can hold 8. And I'll try to draw 8 for you. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now an element or an atom, right, is happiest or most stable when it has 2 in here, 8 out here, and like the next orbital, we can put 8 as well. Okay, so they call it the octet rule. So we're shooting for 8 in the outside. Okay, so if we look at making an ionic bond, okay, so here's sodium. And sodium has 11 electrons. So that means we have 1, 2, right? And then there's 8 here, which would give us 10. And then we have this extra 1 out here by itself. Okay, so it's alone. Okay, now chlorine has 17 electrons. So we can say 1, 2, and then 8 is 10. And then there's 7 in the outer one. And this has 1 in the outer one. Okay, so what happens is that sodium will give up an electron and it'll give it to this chlorine. Okay, so chlorine gains an electron, so it becomes an ion that's negatively charged, and sodium loses an electron, so it becomes positively charged. Okay, so then because we have two opposite things, they are attracted to each other, and that's how we form an ionic bond. Okay, so they're held together by their opposite charges. And that I always think about trying to explain this. When my kids had those little chains, the Thomas the Tank Engine chains, right? There was a positive, like the magnets and how you hook the trains together, right? There's a positive and a negative. But you can't stick two front ends together because they're both like positive. But you can turn them around and then the positive and the negative stick together. So that's how we form an ionic bond. Okay, so we put two ions together. Okay, now covalent bonds, what we're going to do is we're going to share electrons. Okay, and we can share more than one pair of electrons. So we can have single bonds, we can have double bonds, we can have triple bonds. Okay, now these sharing electrons are actually the strongest of all the chemical bonds. So water is an example of something that's put together with covalent bonds. Okay, so if we look here, okay, oxygen has, which they should have put on here how many they had, but 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it has 6 in this outer orbital, whereas hydrogen only has 1. Okay, so what will happen then is hydrogen will share an electron with oxygen 2 times. Okay, so then the oxygen ends up happy with 8, and the hydrogen ends up happy because its orbital is full with 2. Okay, and this is how we form a water molecule. Most of the time we just draw it like this, right? And that's H2O. All right. Okay, now sometimes in a covalent bond, they don't share the electrons equally, and sometimes they do. Okay, so it's kind of like symmetry almost. Okay, so methane gas is CH4. So here's the carbon in the middle, and then the 4 hydrogens are symmetrical around it. So they're nonpolar, so the electrons are shared equally. Okay, so that's a nonpolar covalent bond. Whereas water, the oxygen is more, they call it more electronegative. So it kind of hogs or like wants all of the electrons. Okay, so it becomes slightly negatively charged, which that's what this is trying to show you, and the hydrogens become slightly positively charged. So that's a polar bond because electrons are not being shared equally. Okay, so if I draw it like this, oh shoot, I should have put hold on, right? This is the oxygen, right? And this is a hydrogen. Okay, and to me, this picture is busy. There's a lot going on. Okay, so these are covalent bonds, right? This becomes hogging the negative things, right? So it becomes slightly negatively charged. If I circle that. And these become slightly positively charged, like that. Right? And now you're asking, why do we care? What does this matter? Well, it turns out that this unequal sharing in this molecule is what makes water water, gives it all the properties that it has. Oh, hold on, guys, can't get this slide to go forward. Okay, so this picture, okay, so is trying to show you, okay, so here's a water molecule. Okay, so this is oxygen, right? And these are hydrogens, just so you remember. Okay, so the oxygen becomes more negative, the hydrogens become more positive. So if you have a whole bunch of those, okay, like this, okay, so this is a oxygen or water molecule, this is a water molecule, it's a water molecule, right? What ends up happening is that the negative, remember the opposites attract? Okay, so this positive hydrogen is going to be attracted to this negative oxygen, and they form a third type of bond, which is called a hydrogen bond. Okay, so if we go like this, if I draw you my picture, okay, so here's one water molecule, right? And this is negative, this is positive, right? And here's another water molecule. This is positive, negative, positive, right? we form a bond. Let me make it a different color. How about orange, or I like the pink. Make it blue, which if you're, wait a minute, let me make something other than blue. We'll make it red. Okay, so here, okay, we form a bond here. So these two guys are attracted. And that kind of bond is called a hydrogen bond, which we're going to talk about in a second. Okay, so these are covalent bonds, and they're polar covalent bonds. But this is a hydrogen bond. So a hydrogen bond is between water molecules, whereas covalent bonds make up water molecules. Okay, now they're so important. Okay, so hydrogen bonds are weak. Okay, they're really, really weak, and they're fluid. Okay, so they're kind of moving all the time. And if I, well, here, let me go back. Because they're so weak, what's happening is they're kind of switching all the time. So they're swapping. So like you might have a bond to this one, or you might have a bond to this one, or you could have a bond to this one, depending on when you're looking at it. Okay, so they're fluid. Okay, so one water molecule may participate in several hydrogen bonds, and it makes this network. Okay, and that network is how we get liquid water. And this network is what gives water all of its properties that make it cool. Okay, so now water, what makes it special are these hydrogen bonds. Okay, so one thing that I want you to think about here is at ice cubes, right? So water, it's all the same molecule, right? But we can have it in different states of matter, right? So we can have it be a solid, which would be ice, right? We can have it be a liquid, or we can have it be a gas, which would be steam, right? So, so solid water, we're going to talk about why it floats here in a second. Okay, so we see it in places like Antarctica and the Arctic, or like the polar ice caps. So those habitats, so the fact that the ice floats on like the oceans, it provides a very unique habitat. Okay, and we're going to talk about the chemistry of the water molecule to explain why ice floats here in a couple minutes. Okay, so water, it's all about the hydrogen bonds. Okay, and I already told you this. Within a water molecule, we have polar covalent bonds. So water's polar. Okay, so that's going to be important. Okay, so, oh, I already kind of told you this, but so because of this polar nature, right, we get, and this picture is very, very busy. Yeah, right. I want you to see this hydrogen bonding. Okay, so, and I already told you this, hydrogen bonds constantly break and reform. So we're going to fly over that one. Okay, now, ice floats. Okay, so why does ice float? We will get to a slide where it's on there by itself here in a second. Okay, so these are like these are the properties that you should understand or get, okay? So 1, frozen water floats. 2, water is a good solvent, okay? So it can dissolve things. This should say temperature regulation. Okay, water, because of these hydrogen bonding, it resists changes in temperature. Okay, so it's hard to change the temperature of it. It takes a lot of energy to heat it up. Okay, and then the last thing is water molecules stick together, which is cohesion and adhesion. So I have a slide of each of these. Okay, so the polar nature of water means that frozen water floats. So I want you to think about, like, if you put a can of Coke in the freezer and it freezes, right? What happens to it? Right? It might explode, right? So what happens is when water is liquid, the hydrogen bonds they're moving around all the time, and they're very, very fluid. Okay, But when we freeze it and we lower the temperature, those hydrogen bonds kind of stretch out, right?